Welcome to the Stormsurf video surf forecast for the week starting Sunday, September 25th. First up, we take a look at significant wave heights for the South Pacific Ocean, and we see not a whole lot going on. Little area, 22-foot seas in the far Southeast Pacific, and that's it. And you might ask, why are we looking in the Southeast Pacific or the South Pacific? Because there's nothing going on in the North Pacific, and this is the only source of swell for the coming week or two. There is swell hitting California right now, but definitely on the downswing. It peaked out on Saturday with pretty good size, significant wave height size. That made significant swell number, I believe it was 8 for the season. That is fading out, dribbles by Monday. Now another system developed, and we'll get into this. We'll just take a look at the wave model here. Small little area seas, what is that? Got up to about 28 feet, maybe 30 feet over just this small area. Was that actually 26 feet there on Wednesday of last week? Good enough for a small pulse of swell, and there you go, 28 feet into about midday Wednesday, and faded. But then a secondary system formed behind it, and that was a little bit stronger with 30-foot seas on Thursday. So a Wednesday-Thursday sort of scenario for the life of this storm. That should produce some swell pushing into California at the latter part of this coming week. Nothing large size-wise from a rather southerly direction. And then that system dissipated out. Let's go take a quick look at the forecast now for the southern hemi. And again, we're just going to look at significant wave heights. We're going to focus the meteorology on the North Pacific. Another little gale, tiny little gale, was at 32-foot seas on Monday, Tuesday. That's not really the one we're looking at. Not a whole lot is expected to result from that. It's this one here on forecast 126 hours out on Friday night, 30-foot seas, 32-foot seas over a little bit larger area, lasting a little bit longer, pushing a little bit farther to the northeast. Minimal swell expected for Hawaii and the U.S. West Coast if it forms as expected, and it's still kind of a reach, so that's kind of it. The southern hemi is going to sleep, being how we're almost in October now. That is not unexpected. Next, we focus our attention on the northern hemisphere. One would expect this area to be active this time of year, and it really isn't. There's been no swell-producing systems in the past week in the North Pacific, and let's just get into the details. First, we'll talk about jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales do form, help direct their track. But what we have right now is a split jet pattern. Southern branch here, running good, down at 40 north, but part of the energy that normally would be here is getting split off, tracking up into the north through the Bering Sea. What that typically does is set up high pressure in between the split flows, and that does nothing for swell production. Also notice this big ridge here on Sunday pushing over the U.S. West Coast. A ridge this way would support clockwise flow aloft and down at the surface. That is the pattern of high pressure. So down at the surface, you'd expect high pressure, and that's what we have. And we have hot temperatures in California. So let's roll this out. That high pressure by Monday starts dissipating somewhat. Split continues over the basically the whole of the North Pacific. And here we go. More split energy. Some consolidation trying to get going here. Maybe early Thursday in the far West Pacific. But still just not super cohesive. Trying to look a little bit better into Saturday. And then we get out here into Sunday, and then you go, the split's pretty much dissipating. Notice wind speeds picking up here in the jet in the, about 130 knot range. But what we really need is a good trough, a dip in the jet here. That would set up a counterclockwise flow. That's the hallmark of low pressure, but we're not really seeing it. Yeah, a little bit maybe, but it's kind of weak, and it almost looks like the jet wants to split again here. Why is that? Well, we'll get into it in a minute, but the short of it is the inactive phase of the MJO, and that might be somewhat related to our La Niña pattern that's going on. Let's go take a look down at the surface. Here we go, surface level pressure, surface level winds, and as expected, remember, the southern branch was running somewhere right around in here, northern branch up in here. Here's our big high pressure, 1032 millibars, embedded in a broader generic high pressure pattern at 1020 millibars. High pressure off the U.S. West Coast too. Okay, the only thing of interest is Typhoon Megi Winds 95 knots, forecast to go to 100 knots and move over Taiwan, right, central Taiwan, sometime tomorrow. Anyway, we'll just put this in motion. See, there you go. There goes Meggy. Otherwise, high pressure still dominating. Some sort of a tropical system perhaps trying to get organized here off of Cabo. But the models previously suggested it pretty strong and heading north. Now, not nearly as impressive. A little bit of low pressure here, but at 10, 12 millibars, that's nothing. If you want a real low pressure, we need to get down at least to the 976 millibar range, and that just isn't happening right now with the jet stream flow that we have. Finally, we get into Thursday night. Remember, we saw a little bit of a healing of the split jet. Here comes a little low pressure, but notice wind's very weak in the 25, maybe 30 knot range. It's not enough to do anything. And then finally, there's your 984 millibar low on Friday night, but just a little bit of fetch in the Pacific. Most of it's up in the Bering Sea. And then it finally gets organized. Look at that, 40 knot winds on Saturday, but all in the Bering Sea, all behind the Aleutian Islands. No real fetch aimed at the U.S. West Coast of any magnitude. Earlier runs of the model had this system much further south and moving towards the dateline. That would have produced swell, but as of right now, just a no-go situation. High pressure then off the U.S. West Coast. Let's see what this little bit of low pressure, whoops, you saw that little bit of low falling south here. So once we get into winter, that's kind of what we expect might happen with La Nina, the core of the La Nina cool patch somewhere out in this vicinity here. The worst of the high pressure we would think would be out here in the wintertime, but that might allow what we call backdoor fronts, these low pressure systems. They kind of get skirted through the Bering Sea, then fall down in the eastern Gulf and into California. It's actually good for snow if that pattern sets up and it has a little bit of energy around it. It's much cooler air, so even a little bit of precipitation can generate a lot more snow in the Sierra and up into the Cascades. But that's just speculation. So that's that. Let's go do a quick look at the wave models for the North Pacific. And here we go, significant wave heights, North Pacific Ocean, starting 18Z on Sunday. Here's Typhoon Meggy. All these seas here in the, 43 feet, are all pushing. So all the fetch in this storm, most of it is, remember, it's counterclockwise circulation, so it's all pushing towards Taiwan, China, past the Philippines. Anyway, and as we watch it, that system just goes inland. Nothing for us. Roll this out, and you just don't see any fetch of any interest or any seas. Now, remember that low come the weekend up here in, there you go, 18-foot seas. That's it, and that's not going to generate anything other than maybe for, I don't know, coastal Canada or something. And that was it. So, again, North Pacific pretty much asleep. Let's go examine the reasons why. And that gets us into the La Nina discussion and the MJO discussion. First, we'll talk about the MJO, Madden-Julian Oscillation. It's a weather pattern that goes pretty much 4 weeks on, 4 weeks off across the Pacific Ocean, tracking west to east, from the West Pacific to the East Pacific. 4 weeks of La Nina the inactive phase of the MJO, and then 4 weeks of the active phase following it, tracking west to east across the Pacific. So first off, and this is really what matters more than anything, we look at winds in the Pacific on the equator, 5 degrees north and south of the equator, and of course you see easterly winds. This is from the TAO buoy array, buoys strung across the equator the whole way across, normally used for monitoring El Nino and La Nina. And specifically where we're interested in is what we call the Kelvin wave generation area, right here from about 135 east, just north of Papua New Guinea, to the dateline, right in here. Of course we see easterly winds, but there's always easterly winds there. Deviations from normal, this is anomalies here. Deviations from normal for this time of year, and basically these wind speeds and wind direction is completely normal for the balance of the Pacific Ocean. And for the Kelvin wave generation area, though not all the buoys are active and covering the area, we do see easterly anomalies, weak easterly anomalies, suggestive of the inactive phase of the MJO. And at the end of the day, the only thing that matters is wind speed and direction in this area here. That in the inactive phase tends to make the jet stream split, and that's exactly what's going on right now. You saw the jet stream split in the northern hemisphere coming off of Kamchatka and the Kuril Islands, and that's what we have going on here. East winds. When the winds turn westerly and you have the active phase of the MJO, that actually imparts energy to the jet stream, makes it stronger. It doesn't split anymore. It pulls together, and that helps support storm formation. So the reason we haven't had any storms for the past couple weeks is because the inactive phase of the MJO and easterly anomalies have been in this area, and that's just sort of tearing the jet stream apart, stealing energy from it, making it split, and basically creating a wall headwinds that the jet stream just can't do anything about, and it just falls apart. Here's another way to look at it. The date line is right here. This is a map of the entire planet, but the date line is here, and the Kelvin wave generation area is basically between these two tick marks, and just follow it down. Blues represent easterly anomalies. Oranges, reds are westerly anomalies. These are all in the Indian Ocean. That is pretty much the way La Nina works out. All the energy is over in the Indian Ocean. You get these easterly anomalies in the West Pacific, and that just doesn't do much for the jet stream. The real meat of the problem started here about the 12th of September. Strong easterly anomalies developed in the Kelvin wave generation area. They're starting to back off a little right now, but they're forecast to build again for the next week through the end of the month, and that will continue to keep the jet stream weak and split. This definitely looks like this classic inactive phase of the MJO. If it only started in September 10th, and remember, we've actually, on Monday of last week, we had a pretty good pulse of northwest swell. It was 3 feet overhead up in exposed breaks up in the San Francisco area. I mean, nothing huge, and that was generated, I forget when it was, the Friday before, a little bit over a week ago or so. So the North Pacific, has been trying to do something. But as of starting about the 14th, 13th, something like that, these easterly anomaly have developed, and that's pretty much putting a squash on things for now. Now, the really funny thing is, let's look at this model. The Kelvin wave generation area right on the equator, so right about from here, I'll say from here to about here, this area right here. And we were saying the inactive phase of the MJO is in control. Okay, but you look at this model, this is the statistic model, and the blues suggest more cloud cover, which suggests the active phase of the MJO. And for the next 2 weeks, it's supposed to stay in play. So this is in a direct contradiction with what we see going on at the surface down at the equator right here. At the end of the day, this is why we're saying at the end of the day, all that matters is wind speed and direction down at the ocean surface in the Kelvin wave generation area. That's your best indicator for what's happening in the jet and what's going to continue to happen. This model suggests active phase of the MJO and continuing for the next 2 weeks. Don't believe it. The GEFS model, which is the dynamic model, suggests much the same, but with the active phase fading out. This is outgoing long wave radiation, by the way, cloud cover. More cloud cover typically is synonymous with the active phase of the MJO, but again, we don't believe any of this. Inactive phase, we think, is in control. Now, the phase diagram charts here, again, assume you're looking down on the north pole of the planet, and the MJO travels from west to east, from the Indian Ocean over the maritime continent, consider this like Papua New Guinea, to the date line, into the Pacific, across the U.S., south of the U.S. mainland, over Africa, and back into the Indian Ocean. It makes this whole path in, 4 or 5 weeks, 6 weeks, something like that, a couple weeks over the Pacific. Anyway, where the black dot is right there is where the active phase of the MJO is. So this says the active phase of the MJO is over, let's say, Papua New Guinea, that area, okay? Which is much like what the previous charts just say, but also if you're within this circle, that means it is extremely weak. I'll buy that. And here's the forecast for the next 2 weeks. It's supposed to get a little stronger and then fade out per the ECMF model. The GEFS model says, yeah, pretty much the same thing, but even weaker still and incoherent. So if the active phase is around, it's pretty much over land west of Papua New Guinea and not expected to really make any headway, or if it does make headway, it would be so weak. So that might explain why it appears the inactive phase is in control. Here's yet another view, this from the CFS model, 850 millibar winds, that's up about 4,000 feet. Again, Here's the date line here. Now this chart goes past history on the bottom. The forecast is the top. And you see, so Kelvin wave generation area, about 135 east to 170. So between those two are roughly right in here. You can see easterly anomalies right there. We'll overlay the MJO. There you go, inactive phase of the MJO. Now this model suggests there's supposed to be some active phase of the MJO developing in the Kelvin wave generation area. Oh, I don't know, in the next week or so. But again, you notice no westerly anomalies. These blues are easterly anomalies in the Kelvin wave generation area, or neutral. That's kind of just more of the same. You get past there. Now this is, yeah, that's the active phase. Then another inactive phase, but very weak. I mean, all these phases, you know, the MJO is just very incoherent, not having much effect, if anything. Now, this model's been continually suggesting westerly anomalies developing in this area. We're not buying any of it because it just says it, and then you get, you know, a month later when it's supposed to be here, it never develops. Easterly anomalies, weak easterly anomalies in control. This is pretty typical of what happens during La Niña. La Niña is biased in favor of the inactive phase of the MJO, just like El Nino is biased in favor of the active phase of the MJO. And last year, we had some very strong pulses of the active phase of the MJO, a lot of westerly wind bursts, and that, you know, really fed the jet stream, a lot of good storm activity in the fall and winter months. This year, then it's pretty normal after El Nino. You spring back into La Niña, and normally it's a pretty strong La Niña if it's a strong El Nino, and last year's was a very strong El Nino. Now, it didn't necessarily impact California the way everyone thought it would. It was westward displaced. This year's La Niña appears to be westward displaced, but it's not that strong, which is kind of a good thing. I'd rather have a weak La Niña than a strong La Niña, because a strong La Niña just shuts down precipitation. It shuts down the swell production machine. And really, you look at this pattern here, and yeah, it's not, you know, not strong one way or the other. It's just kind of weak and in the middle, and but, you know, things could be a heck of a lot worse than what we're seeing. So we'll take it. We'll take our licks because we got to. You know, you're going to get La Niña. If we end up with a weak La Niña, and if that's the worst of it, I'll be happy. That's a good thing, because then a year or two after that, we start moving more back into a normal pattern. But if you get a strong La Niña and, you know, cold water, a lot of easterly anomalies, it takes a lot longer to recover from that. So, and of course, the thought is the PDO, an even longer oscillation, a 15 to 25 year oscillation, we believe that's moving into the active phase and sort of dampening La Niña, which again is good news. So we've talked about the MJO, we've talked about winds and all that sort of stuff, but let's take a look down in the ocean, because the La Niña has a definite impact on what goes on in the ocean, not at the surface, at depth. So here we go, West Pacific here, East Pacific here, down 100, 200, 300 meters. This is actual water temperatures. You can see these are buoys strung across the entire Pacific on the equator, 2 degrees north and south. These little X's are the sensors on the anchor lines of those buoys, and you can get a sense of what the water temperature distribution is doing. You clearly see warmer than normal water here in the far West Pacific, cooler, well, now you see warm water here, and less warm water in the east here. The thermocline, the warm water field is very shallow in the east and much deeper in the west. Here's differences from normal for this time of year. Now, a week or 2 weeks ago, this, you know, there was kind of a break, and there was a pocket of cool water here, a pocket of cool water here, and sort of neutral in between. But now, again, we've got this kind of river of cooler water. But I mean cooler, not super cool, a degree or two, maybe 3 in one little pocket. And at the surface here, notice it's near normal here, certainly warmer than normal here, but we would expect that during La Niña. La Niña typically puts you get a lot of easterly winds blowing. That creates a lot of upwelling in the East Pacific off the Galapagos, cooler than normal water temperatures, and all the warm water piles up here. During El Nino, the exact opposite happens. All the warm water here falls to depth, tracks in here, and you get this big pocket of warm water here. Kelvin waves is what is how that warm water is transported to the east. Now what we have is sort of the opposite of a Kelvin wave. They're cool water Kelvin waves, if you want to call it, and they're not really Kelvin waves, just sort of the static pool of cooler and normal water. But at the surface, it's materializing as neutral or just, what is that, half a degree below normal right here? That's not really a La Nina at all. If we had 2 or 3 degree below normal water temperatures in this area, that would be a real La Nina. Here's another model to basically depicts the same thing. You got this cool water pool flowing west to east, little pockets of warm water, but there's the balance of your warm water at the surface. Here's history. Upper ocean heat anomalies. This is the upper 300 meters of the ocean. Back last year around this time, cool water was in the West Pacific, warmer than normal water in the East Pacific. Kelvin wave. That was Kelvin wave number 5, Kelvin wave number 6. And then here comes the onslaught of La Nina, the cool phase. And the cool water just rushed to the east. But here we go down in time. And that was a big push. Kind of made a secondary little push here back in August. Here we are in September, and things are actually looking weaker. You're getting a little bit of warmth here and here. And, if this is La Nina, this is a pretty anemic La Nina. Temps are a half, maybe 1 degree, and this is down 300 meters. This isn't even at the surface. Not too bad. It looks like the strongest part of it at this point was back in June. So more to follow. Surface water temperature anomalies. So it is, again, just this area, 5 degrees north or south of the equator. So the Niña 1.2 region is right in here. And what you see is a lot of warmer than, you notice, you can't miss all the normal than warmer water everywhere. That is a different story. We're not going to go into that, but clearly the oceans are warming. They have to keep adjusting the climatology because the oceans just keep getting warmer and warmer for reasons that I'm not going to go into. But we do notice a thin little cool band here along Peru. If this is La Nina, that's the weakest La Nina I've ever seen. Normally it's going to fill this whole area here. And really, the pipeline, so you get easterly winds, strong easterly trades. It starts upwelling here along Peru, makes it over to Galapagos, and then is supposed to come the whole way out to this area. You don't see any of that, just little pockets. Really, the only cooling you see starts about 120 west, south of California. Goes out from there, and even that's kind of anemic. This is why we're saying we have a westward displaced La Nina, because normally all this is supposed to be in here. Instead, it's way out here south of Hawaii. The trend over the past 7 days, warming actually along Peru, warming along the Galapagos, little pockets of cool. I mean, these cooler pockets were a lot stronger a couple months ago in June time frame. Now, if anything, we have pockets of more warming, and it's like La Nina is dying on the vine, according to this. Now, the other thing we do is we look at what's going on here off of Africa, and we see a warming pattern here suggests that, if nothing else, the pulse of La Nina or the MJO, you'd think it'd be cooler with the inactive phase of the MJO going on, but that's not the case, and this sort of predates what might be going on here. So warmer here, maybe this will continue for a little bit. And then finally, the broader view. Here you go. Here's your cool pool. La Nina is the cool phase. Here you go. I mean, this is pretty weak, anemic, not impressive at all. You'd expect it to be raging in this area. Instead, you have none of that. You have warmer than normal temps. Not much warmer, maybe half a degree or something, but, this just doesn't look like La Nina. Here's the actual temperatures in the Niña 1.2 region. This is the Galapagos, Peru, that area. You can see temperatures have yet to fall negative by any margin. Yeah, they're bobbling around and cycling, but there's the neutral line. That's normal, and we don't see anything negative. The value, plus 0.018, dead neutral as of right now. Here's the Nino 3.4 index. That's from like 120 west out to 170. That's where you normally use to measure El Nino or La Nina. And these temps, current, they're above normal here, barely, plus 0.394 degrees. And you see, notice there is fluctuation. These fluctuations pretty much track with the active and inactive phase of the MJO. But generally, the temperature, if you drew a line through all this, it's somewhere around a half a degree, which again is just barely La Nina territory. So we've talked about subsurface ocean temperatures, we've talked about ocean surface temperatures, but those temperatures affect the atmosphere above it, okay? So what there's this index, Southern Oscillation Index. It's the difference in pressure between Darwin, Australia, and Tahiti. When the numbers are positive, like you see here, like today's value, that suggests the inactive phase of the MJO, okay? And you can see it's generally, though, the trend has been positive for a while. If it stays positive for a long enough period of time, then you're into La Nina. The 30-day running average, plus 12.62. Again, more high, but not super high. The 90-day running average, plus 6.52. If it stays... So you can watch the MJO through the Southern Oscillation Index. If it stays positive long enough, then you're into La Nina. This suggests a very weak La Nina. The ESPI index is much the same, only it's tracking total precipitation in the area north of Darwin, Australia, and then the area north of Tahiti over an expanded area. When you have drier than normal conditions here, wetter conditions over here, then that's indicative of La Nina. The reverse is El Nino. When the numbers are positive, that suggests El Nino. When they're negative, it suggests La Nina. Minus 1.34 today. This has actually been down a bit from what it was a month or so ago, but not markedly so. We've already been down at minus 1.5, and we're still not there yet. So this is suggestive of a weak La Nina as well. One note on the 30-day Southern Oscillation Index, you can see the trend. This is over 2 years. Here was back in January 2014, the start of our El Nino. Big push negative. We kind of rebounded, and then we continued to gurgle down and down and down into October 2015. And here we are last winter. And you can see the pulses of the MJO in this cycle. And then come about May of this year, major inactive phase of the MJO, continuing upward here. And so you can see there's the downward trend of El Nino here. Now the trend starting to head up, suggestive of La Nina. The final chart for this evening's presentation, the forecast for the Nino 3.4 region from the CFS version 2 model. Here we are right in this time frame here, like expected. Sea surface temperatures back in a year ago. Very positive, suggestive of El Nino. Falling off through the spring, down to minus half a degree. And here we are right now, still at minus half a degree. The forecast suggests, now it was suggesting this was as cold as it was going to get, but just in the past week, it's now suggests we're going to dip a little bit more into, in the November, December timeframe down to maybe 0.7, 0.75, something like that. The consensus of a bunch of other models suggests about the same thing, about 0.6, something like that. But again, that's a weak La Nina. If you were down at 1.5, 2, then we'd start getting worried. Remember, you have to go in 3 months, 3 consecutive 3-month periods at minus 0.5 or more to officially be declared a La Nina. We're barely going to make that in this time frame here. NOAA right now is saying we're not even in La Nina. We're in a neutral state, but we're going to say we're in a weak La Nina. All the other indicators in our mind suggest a very weak La Nina. But anyway, you get in January, and then supposedly this thing's all over, and by next year, we're supposed to start warming. We don't believe that, but I bet we will hang in neutral. And, if that's the extent of our bounce back from El Nino, is a 1 winter, half a degree La Nina, that's a small price to pay, and that suggests that we could be into a much better pattern over the long term. It also suggests that, one, our La Nina is westward displaced, which makes it weak. But the question is, why is it westward displaced? Why is it so weak? Well, we've been saying this every time we do this forecast. We'll say it again. We think the PDO is turning to the active state. We pay this little price, and after this, then it could be 15 to 25 years of a much stronger storm pattern for the North Pacific Ocean. But that's speculation at this early state. We need more data. Probably it'll be sometime June or so of next year. Then we could probably have a more definitive answer for you. Anyway, for now, small southern hemi swell, or actually it was a stronger southern hemi swell starting to fade. Another pulse of southern hemi-swell coming for later in the week into the weekend, but not as big as what we just saw. And then maybe another smaller pulse after that. North Pacific, kind of quiet, waiting for the jet stream, waiting for the inactive phase of the MJO to sort of do its thing and get over with, so maybe we'll get something out of the North Pacific. Hard to say. La Nina kind of stomping on stuff for right now. But that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.